Hello, this is a lesson on day 4 in Unit 4, which is Chapter 3B. And it's on critical points and extrema, or really just extrema and increasing, decreasing intervals. So it's talking about maximums and minimums, either an absolute, meaning the highest point in a graph, or the lowest point in a graph, or a relative maximum and a relative minimum, which would be basically a high point or a low point, but not necessarily the highest or lowest. So in a graph, let's say it just kind of looks like something like that. This will have a few examples of everything we are talking about. An absolute maximum in this case wouldn't exist, because maximum is talking about like the highest points, and you can see the tail ends of the graph, the end behaviors, go up to positive infinity. So in terms of an absolute maximum, it wouldn't have one. Whereas a graph like maybe if you're upside down and it went like that, this one would have an absolute maximum. It would be right there because it's the highest point. And there's another maximum over here, but it's not the highest. So you can just say the highest point in the graph, or on a graph, on a curve. And then a absolute minimum would be the lowest point in a graph. So that would be that guy. You can see that there's another minimum over here, but it's not the lowest. Lowest point on a graph. And both of these examples will have an example of a relative max and a relative min. So you could see that, maybe not red, maybe purple. This point right here, it is a high point. It's higher than other points of the graph, and then it goes back down, but it's not the highest, because these go on, infinitely towards positive infinity in the y direction. So obviously this point isn't the highest, but it is a peak. So we could say, we can just very non-technically put would be just a high point. Similarly, we would have a relative minimum here as well on the same graph, because it is a minimum. It does go lower, but it's not the lowest, because that would be the green point we already put there. That'd be an absolute minimum. So this over here, the orange or gold color, is a relative minimum, a low point. Okay, and we would just want to know, the ordered pair of that point. And so, what's that guy? And this is that one. Similarly, on this other mini graph I drew, this would be a relative minimum. It's gold. And a relative maximum would be this point. Again, because it's a peak, but it's not the highest peak. And this one, the gold one, is a valley, but it's not the lowest point on this graph. It dips down, but doesn't go. It's not the lowest point that it dips down to. It would go to negative infinity on this graph. So that's relatively basic, and we just kind of described it in a very easy way. The highest point on a graph is absolute maximum. The lowest point, if there's a lowest point, that's absolute minimum. And relative max is a high point, but not the highest, and a relative minimum would be a low point, but not the lowest. And there are intervals of increasing and decreasing. So if you had another example of a graph, let's just say something like this. This is next to the third graph. We want to see it goes up to these extrema, and just from left to right, let's say maybe this is at -2, 1 or something. This is 2, -1. A decreasing interval, and this kind of goes to interval notation. We would say it goes from -infinity. So this isn't an ordered pair. This is like interval notation. -infinity we're talking about the x direction here, over to -2 is an increasing interval. I put it in the wrong spot. And this is because it's when you're going from -infinity, you see the graph is going up, and then it kind of hits it starts turning around right here and starts going down in the y direction. So that will be the point in which it starts decreasing. So that interval, and I'll explain about the parentheses and brackets in a second. That interval goes from -2, it starts decreasing now, it starts going down, and then it hits this point down here, which is when x is +2. And then it stops going down, it stops going south, and that starts turning positive, or starts increasing, going north again. And these brackets, the brackets is when there's a definite point, when it hits that point exactly when it starts turning around. And a parenthesis means it's not exactly, it approaches that point, but it doesn't stop on that and turn around. And obviously the infinities will always have to be a parenthesis because it's not a definite number. It's just indicating that it goes on forever. But the problem with this graph is that we do have, from left to right, we have increasing from -infinity to -2. So it's going this way, increasing, 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 and then it stops and turns around. Now it's going decreasing until we get to +2. And then it stops decreasing and it starts increasing again. So we have the increasing from -infinity to -2, and then it starts decreasing from -2 to 2, but then it starts increasing again. And that's a U. It's a symbol for the word union. So it just means including for us right now. And it starts from 2, starts increasing at 2, and then it increases forever in this graph. So to infinity. And I have to have parentheses here because infinity is not a definite number. So the increasing has 2 parts to it. The graph is increasing from the leftmost side, and then after 2 to the rightmost side, and then to infinity. The decreasing part only happens, it only dips back down in the middle. If it didn't have a decreasing part, it would just look like, it's just going straight up like that forever. A similar, I guess, example, this would have, well, let's just do a parabola. Let's say this is 0, -2. This in particular, this example, it would be decreasing from -infinity to 0. And it would be increasing, because that's where it stops, decreasing and starts going back up from 0 to infinity. This would be a bracket because it's definite, and the infinity would be parenthesis because it's not definite. And you see that there's no unions here because it doesn't go back to either decreasing or increasing. There's only it only changes direction once, so it kind of stops like that. So these are more attributes of like a graph, and that's why its unit's kind of called the nature of graphs. We're finding all these attributes of graphs that we can describe. So look at the extrema for a graph of and name and classify the extrema of the function. So first of all, we could say that Obviously we have this going up forever on this side. So that tells me if it goes up forever, we're not going to have an absolute maximum. It goes up forever. So, and abs max is not going to exist. We could check for an absolute minimum. So we just want to see if there is a lowest point of the graph, and we see that it goes down forever on this tail end of the graph. This is a piecewise function, so there's kind of different parts to it. And if you remember, this would be a jump discontinuity, but there is no absolute minimum because this goes down forever. So we could test for a relative, a rel max. A relative maximum would be a high point, one of the high points of the graph. Like, other than going to infinity, is it the highest? Is it a peak or a valley? And we would say that and we're looking for a definitive points. So we see that the graph goes down, and it turns around down here. So this is something, but it's not the highest point, not a high point. It's a low point. And it goes up to right here, which is a high point, not the highest, because it goes to infinity on the left tail end, but it is a high point. So a relative max would be at 1, so 1, 6 it looks like. And then we can check for a relative mins. I wouldn't I wouldn't call this point right here a relative maximum. It's a high point of the graph, kind of, but it's not a point. You see, it's undefined. This part of the graph is undefined at 2, where you're at, or at 1. I mean, when you're at 1, it's up here. So this wouldn't count. A relative min. We have a dip in the graph right there. It's we see it's decreasing up to this point, and it stops and turns around. It's decreasing up to a relative minimum, and then it starts increasing again. So the relative minimum would be -3, -2. And we look at the rest of the graph, we see that there is no dips or valleys. It's just a line that goes down here forever, and that's why there's no absolute minimum, because it goes forever. So this particular graph, we only have relative max and relative min, and we figured out the points where they're at. So that would be the extrema. This looks like a fun one. So let's look for the extremities, basically the limbs, the peaks, the valleys. So there's a valley, there's a peak, and we see the tail ends of the graph go on forever in those directions. So that tells us right now both positive infinity and negative infinity are covered by this graph. You see the left tail on the graph goes to positive infinity, so there is no absolute max. There is no absolute minimum because it goes to negative infinity. But in terms of a relative max and a relative min, we could see that this point is a low point. It's a valley. So all other points are not less than this point unless it's going to negative infinity. So this point right here would be a relative minimum, ends at -1, -3. And we have a relative maximum over here at 3, 3. And then the graph continues on going to negative infinity, so that's why we don't have an absolute max or absolute minimum. We only if it's a definite point would we categorize it as an extrema. It goes on forever. We don't have absolutes. Okay. Use a Desmos graph. Use Desmos to graph a function. Determine and classify its extrema. Then list the intervals of increasing or decrease and give the end behavior. Whew, that's a lot. There's 3 things: extrema, intervals of increasing, decreasing, and then end behavior. So we wanna just see what this looks like on Desmos. And so we gotta type this guy in. 2x to the third minus 5x squared. Minus 1. Okay, and so Desmos is great. we can get a general idea of the graph. You see it's like this. It's on the left tail end of the graph. It's going down forever. It's an odd function, and it's not a negative leading coefficient, so we can tell certain things just by the classification of it being odd and a positive leading coefficient. We already know the end behavior before even graphing it from a previous lesson. So the notation for that we've used is as x approaches negative infinity, and as x approaches positive infinity, what's the graph doing? So I'm choosing to do the end behavior first because it's easier. It's odd function. So as you approach negative infinity in the x direction, where's the graph going? And it's going to negative infinity. As x approaches positive infinity, as you start walking out in the positive x direction, where's the graph going? To positive infinity. Okay, got the end behavior. We'll need to know some intervals and its extrema. As we look at this graph, we see it goes negative infinity and positive infinity. There's not a single highest point or lowest point, so we don't have any absolutes. We do have relatives, those two peaks and valleys. So we would say that this is a high point. We have a relative maximum at 0, -1. And we have a relative minimum at 1.6 repeating, -5.63. And then the last part, intervals of increasing and decreasing. So it's, let's see. So this is increasing. So as we go from the left side of the graph, we were at negative infinity and we're climbing up. So this is all increasing up until we stop increasing and we start decreasing. So that extrema right there is where it stops. So we'd say increasing from negative infinity to the relative maximum, 0. Then it starts decreasing. Decreasing from this extrema to basically to the next extrema, or extremity. So it's decreasing from, oops, that would be a bracket. Decreasing from 0 to the x value of the relative minimum, where it starts turning back around again. So that's the lowest point relatively before it starts going increasing again. So that's a 1.6 repeating. It's decreasing, so it's going down, it's decreasing, decreasing, decreasing. Then it starts increasing again. So we have another interval of increasing. So this is union. Oops. Union doesn't really have a tail. It's just a symbol that looks like a U, but not quite a U. At the definite point, it begins 1.6 repeating, and then it climbs. It goes on forever to positive infinity. And again, just a note: when we have the definite points of where it changes its increasing or decreasingness, they should be brackets. It's a definite point at which it changes. The parentheses for us are reserved for the infinities because it's not a definite point. It goes on forever. So we did it. We have a ton of information, but this is all, this is like 3 sections worth of stuff almost, even though we did extrema and increasing, decreasing. There's 3 attributes to describe our graph that we now can do. And we could graph this on here, 0, -1, and 6, 7, -5, it's somewhere over there. So something like that. But I would just copy, take a screenshot of this and paste it over. All right, we got another example here. X fourth, x third, 3, -2, 6. X third minus 2x squared. Hopefully I typed that right. All right, looks good. My graph's a little, I can't really see it all, so let's take a look. Oh, lots of stuff happening. I'm gonna squash it in the Y direction so I can get it all on the screen. Neato, huh? And then I'm gonna hit some points so I can actually see them. Hey yo, that point, that point, that point. Desmos is really great for us for this section because it tells us our extrema. It tells us where it starts changing, increasing, and decreasing. That's why extrema and increasing, decreasing are in the same lesson. They're related. They're referring to the same points of changing, increasing, or decreasing because that's what dictates whether or not it's a relative maximum or absolute maximum or minimums. So, first of all, we could, before we even graphed this, we knew it was even and it's a positive leading coefficient. So they're both going to positive infinity. So as x approaches negative infinity, and as x approaches positive infinity, what is f of x doing? What's our function doing? It's going to positive infinity and positive infinity. That's the end behavior. Let's do increasing, decreasing next. I'll do decreasing, increasing. The order doesn't matter. And as we look, we see our graph starts really high and it's going down. So it's decreasing the whole time until it hits negative 2.63. So decreasing from positive infinity to negative 2.63, definite point. Then it starts increasing from the same spot that we stopped, from left to right. It starts increasing up to when x is 0. Negative 2.63 to 0. All right, then we have another change in the graph. And if we did spread this out, you can see it dip down a little easier if we look at it that way. But I have the points, so we can look at them still. It starts dipping down again. It starts decreasing again from 0 to 0.38. So decreasing also 0 to 0.38. And then we start increasing again from there on out. This would go from where we picked off, where we stopped off, it was at 0.38, and then we start increasing forever. So definite point 0.38, comma, goes up to infinity, parenthesis. All right, and we kind of already have some of these points, but Desmos will tell us. I'm going to zoom back down, grab that point, grab that point, grab that point. We have, in this case, since there is no lower point on my graph than this negative 2.63 extrema, that is the absolute minimum. There is no part of the graph that goes lower. So it is an absolute. We have an absolute minimum at the point negative 2.63. And just clarification, these are points, so I'm not gonna, there's no brackets in this. That's only for interval notation. And it goes negative 14.565. And so this is just the ordered pair that is the absolute minimum. Then we have a maximum, because then it's a peak and starts going down a little bit right there, but it's not the highest point because we have, obviously, it goes up forever. So 0.6 would be a relative maximum. 0.6. In the next part, we have another minimum because it's decreasing there and then stops, turns around, goes up. So it's kind of a little dip, but it's not the lowest point. The lowest point's down here, but it is a low point. So we would say that this point is a relative minimum. 5.897. Relative min 5.897, and that was at the x value 0.38. Wow. Okay. So again, I'm not going to necessarily attempt to draw this Desmos graph as well as Desmos does it. However, you can screenshot it, and this is kind of fun. Doesn't take much. And there's my graph. So I just put that right there. And we can definitely see what we're looking at. And I described a lot of this using different notations. And, you know, if you walked into class someday not knowing anything about this and you looked at all this notation on the board, probably vomit a little in your mouth, but it's not super complicated, especially if you've been coherent during the previous lessons. It's this was end behavior. This was increasing, decreasing, obviously, and this was extrema. So those are the three things. If it asks you end behavior, we're talking about what's it doing on the tail ends of the graph. We're talking about increasing and decreasing, we're using interval notation. That would be kind of new, but it's just basically we just need to know some intervals in which it is increasing and decreasing throughout the whole graph. And the extrema are absolute or relative minimums and maximums. And we won't always have, you know, all of them. For instance, if I, you know, an example of something that doesn't have any extrema would be, how about this one? Would be a good example. Just a line. Line's a good example of having no extrema because there's no absolute maximum or minimum. It goes on the left side goes to negative infinity, the right side goes to positive infinity forever. And there's no peaks or valleys, so there's no relative mins or max. It just goes one direction. All right, I hope this video helped. It's kind of a lot of information, but good luck.